Good afternoon, everyone. My name's Andy Wilkinson. I'm here to talk to you about documenting RESTful APIs this afternoon. I work for Pivotal. I'm a member of the Spring team. I spend most of my time working on the Spring Brute project, but I'm also the lead of the Spring I/O platform and of the Spring RESTdocs project, which I'll talk to you in a bit more detail later on in this presentation. Back when the Spring team were part of VMware, I worked on a RESTful service for managing and provisioning middleware. And one of the biggest challenges we actually found in that wasn't managing or provisioning the middleware, it was actually documenting the RESTful API that we'd written and producing documentation that the users could figure out exactly what they wanted to know quickly and easily. We could tell them the things that we wanted them to know without kind of encouraging them to kind of adopt any bad practices. And a lot of the experience that we learned from working on that has kind of informed my opinions on how you can document a RESTful API, things you can do to make it easy, things you shouldn't do. And I hope to pass on some of that experience to you this afternoon. I'm going to kind of divide this afternoon's presentation into three chunks, really. To begin with, I'll talk a bit about your API, what state it is, and things that you can do and shouldn't do to make it easy to document. We'll then spend a bit of time looking at some examples of good and bad API documentation and tools that you can use to produce that documentation. And at the end, we'll take a deep dive into the Spring RESTdocs project. Well, I'll do a bit of live coding and show you how you can add Spring RESTdocs to a project that implements a very simple RESTful API using Spring Data REST. So I think one of the first questions to ask yourself when you're thinking about documenting your API is exactly how RESTful is it? And that's important because the tools that you can choose to document your RESTful API vary depending on exactly how strictly it adheres to the kind of the official definition of what it means to be RESTful. So back in 2008, Leonard Richardson kind of coined this concept of the REST maturity model that has 4 different levels in it. Now, if you're a REST purist and you stick to the letter of Royal Fielding's research, then you need to be at level 3 to actually claim that your API is RESTful. But I think there's some room for maneuver here. It doesn't have to be black and white. There's gray areas. And I think, so of these 4 levels, level 0, that's kind of your XML RPC SOAP. I hope no one in this room would claim that SOAP or XML RPC is RESTful. That's where you've got a single endpoint that you're talking to, and everything is basically described in the request body. So you send a request body, all sorts of different request bodies to the same endpoint, and that determines what the service does. If you take the kind of the next level up, you're now using separate resources. So rather than talking to a single resource, you've broken your API out into multiple resources, but you're still describing exactly what should happen in the body of the request. You're not making any use of all the different HTTP verbs, which would bump you up to level 2. So at level 2, you're using separate resources, so you have multiple URIs that you're talking to, but you're using HTTP verbs to describe what should happen when you send a request to a particular resource, to a particular URI. So if you want to get some information back, you send a GET request. If you want to delete something, you send a delete request. If you want to create something, you send a POST request. So the thing that you're talking to is in the URI, and what should happen is kind of encapsulated in the HTTP verb. And then bumping you all the way up to level 3, that's when you introduce hypermedia. So you start using links in your API. There are a couple of benefits here. It lets you embody the state of your application. The presence or absence of a link can help to describe some state. So if a particular transition isn't possible, then you don't include the link that would be used to access the resource that would allow you to make that state transition, for example. And also, including hypermedia in there lets you evolve your API without breaking any clients. If people write their clients to follow links, then they just look in the response for a particular link. They're not looking for a URI. They're looking for a link with a particular label associated with it, a link relation. They look for that link and they get the URI and then they perform an operation on it. At no point in your client should you be hard coding those URIs, you should just be following the links. And that lets you restructure your URIs, change things, maybe direct them to a different service because you've split things up. And if they're encouraged to use links and just look things at the right label, you can roll out those changes and well-written clients won't be affected. So I think there are very real benefits to making it to level 3, but I think for the purposes of this presentation, if you're at level 2 and you're using HTTP verbs, then it is RESTful in a kind of a loose sense of the word, and I think that some of the approaches that we talk about here will be of use to you for documenting your API. Another thing to consider is, you've figured out how RESTful your API is today. Hopefully, if you've got one in mind, you'll be able to kind of allocate it to one of those different levels. It's also worth thinking about how RESTful you'd like your API to be in the future. Perhaps you have aspirations, perhaps you're level 2 now, and you have aspirations to make it to level 3. You don't want to pick a documentation tool that will only support a level 2 API, and then think, oh, we want to go to level 3, but now we're going to have to rewrite all of our documentation. So when you're considering the tool to use, 2 things to think about: how RESTful your API is today, and whether the tool can serve your purposes well, and also how RESTful you want to be, so that you don't kind of back yourself into a corner and pick a tool that then makes it more difficult for you to evolve the API as you'd like to. So I'd now like to talk a little bit about some design decisions that you can make when you're writing your API, some things that you can do to lessen the burden, the documentation burden, so you don't have so much to do. Things that will make it a bit easier, give you less documentation to write, and hopefully also a knock-on effect of that is it will make things easier for the users of your API. Probably the most important thing you can do when you're producing a RESTful API is be consistent. 2 main benefits. If you are consistent across the whole of your API in how you do something or use something, it means that you only need to document it once. You don't need to describe it for every single resource because it's a consistent behavior across the whole API. A benefit of that for your users is that then they learn how you've done something once and you approach something once, and they don't need to relearn it for every single resource. The knowledge that they've learned by interacting with one piece of your API can then be applied across the whole of the API, so you make things easier for your users as well. 2 main areas I'd focus on for consistency are your use of HTTP status codes and HTTP verbs. So the HTTP status codes are very well defined, pretty well understood. Anyone who's working with a RESTful API, I think it's safe to assume, would understand that an HTTP 200 is an okay response, and it meant the request worked, and here's the response. I would encourage you, wherever possible, don't do anything kind of off the golden path with HTTP status codes. Don't go inventing your own status codes. Don't go bending the meaning of any of them, because people will come to your API with certain expectations about the responses that they're going to get back. And if you start using an HTTP 500 when something in the HTTP 400 series would have been more appropriate, 1, you're going to have to document that because it won't be expected, and 2, you're going to really annoy your users because any of the previous knowledge that they had, they're going to have to forget all of that and kind of adhere to your slightly eccentric view of the world. Same with HTTP verbs. I talked a little bit about when you get up to level 2, you're now starting to use those verbs to control what will happen. So you use the get HTTP verb for accessing things without making changes. Use post to create something. Use delete to delete something. These are all kind of well-established, well-adopted conventions. If you stick to them, you may not even need to document it at all. The only one thing that you might want to document is the difference between put and patch. This is one area where the HTTP spec isn't perhaps as precise as it could be, and one is typically used for completely replacing a resource, and one is typically used for making a partial update to a resource. But there doesn't seem to be a unanimous opinion on which way round it should be. So if you support updating a resource that already exists, then I would strongly recommend documenting how you're interpreting put and how you're interpreting patch, and doing that consistently across the whole of your API. If you're using hypermedia in your API, then you'll have links. And I talked before about the kind of the labels on the links, the relations they're called on a link. And that relation is kind of the label, and it's how someone identifies that link and what sort of resource it will go to. It's really important that you make those relations distinct so that whenever someone sees a link with a particular relation, with a particular label, they know exactly what sort of resource it's going to go to. And if they're on resource A and they see a foo relation, then that should go to the exact same thing as if they were on resource B and they saw a foo relation. To give you a concrete example, here's the index. So this is the root of a RESTful service for notes. So you have notes, and then you can also associate tags with notes. There are a couple of links of interest here, the notes link and the tags link. So that's two relations. The notes link gives you access to a resource that will provide you access to all of the notes in the system. The tags link gives you a resource that provides access to all of the tags in the system. Now, if we consider looking at, this is the links from a response for a particular tag. Now, a tag can be applied to one or more notes, so you want to link from that tag resource to all of the notes that have that tag applied to it. It might be tempting to put a relation on that link of notes, but we've already used that in the index for the resource that provides access to all of our notes, not just the notes with a particular tag. So here we've taken care that rather than reusing the notes name, label, relation on the link, we've called it tag notes, so that you know that this is the particular resource that you're going to go to if you follow a link, and you don't need to be aware of the context of the resource that you're in when you're trying to figure out if you follow a particular link where you're going to end up. So now I'd like to move on to talk about things that I really think you should document. These are kind of the most important things that you want to cover in your API documentation to help your users get started quickly and as efficiently as possible. Probably the thing that I think you should kind of document first is anything that cuts across the whole of your API. And this kind of ties quite strongly back into the consistency stuff I was talking about earlier on. If you're consistent, then the number of things that cut across your whole API increases because it applies to every single resource. So this is stuff that you only need to document once. So we talked before about use of HTTP status codes. You may not want to document this at all, other than maybe a short, brief mention that we're using the standard HTTP status codes, we're not doing anything crazy, and that might be enough. You don't need to mention it anymore. HTTP verbs, you might want to, if you're supporting put and patch, you might want to describe exactly the behavior of put and exactly the behavior of patch that you've adopted in your API. Other things that might cut across the whole of your API, authentication and authorization. Do users have to authenticate to access your API? How do they do that? Typically, you would authenticate in exactly the same way for every single resource in the API. So you can describe this once up front in an overview section, and then maybe link back to it in each resource, or maybe just not make any further mention of it. Rate limiting is another example. If your API, if you rate limit requests and you're only allowed to make, say, 1,000 requests in a 15-minute period, how are you going to convey that information to users? How should they figure out how many requests they've got left? You might be using HTTP headers to describe the remaining limit when the window will reset, etc. Something that you should adopt consistently across the whole of your API, and it lets you document it all up front in kind of an overview section, and then just refer back to it if necessary. You don't need to mention it for every single time that you're documenting a particular resource. So the next thing I think that you want to document is each resource in your API. So you need to tell people, what do these resources represent? And this is your opportunity to map your user's mental model of what your API is doing to your RESTful API, to your API. So if, for example, a couple of examples, Stripe, the payment processor, have a quite nicely structured RESTful API. And if you think of a payment processor, you immediately think of things like credit cards and billing addresses and transactions and payments and refunds. And if you look at their API documentation, that's how it's structured. It's structured in terms of all those things that you'd expect to find. It isn't structured in terms of the URIs. It's structured in terms of, there's a section in the documentation for dealing with billing addresses, a section in the documentation for dealing with credit cards and expiry dates. So it very quickly, if you go into the documentation knowing that I'm trying to use their RESTful API to process payments, you can immediately navigate to the right piece of the documentation. GitHub's API is another example. They have a very nice RESTful API that's well documented, and the documentation talks in terms of all the things that you'd associate with GitHub. It talks in terms of issues and pull requests and repositories, things that you're already familiar with, so it makes it very easy to get started with the documentation and find exactly what you're looking for. So it's in terms of the structure of the resources and mapping what they represent to the user's view of the world. You also need to describe what input they accept and what output they produce. So this is talking about, you might have a custom media type for your API. So that's something that's very important for you to document. You need to describe to users what does this particular resource expect to find in the request and what output can a user expect to get back. You might want to document things like query parameters as well, use of any HTTP headers that are specific to this resource, any constraints that you might have on any of the request body content. You might also want to describe here, you might have decided to adopt a standard format for your responses. If you're using hypermedia, you might be using HAL, Hypermedia Application Language, as a format, which places certain requirements on the structure of the response body. It determines the format of the links will take in the response, and a few others like embedding resources within the response. If you've done that, then you want to let people know that that's the format. That might be, hopefully, if you've done that consistently, it might be something that you can just document up front and then apply to every resource, but it's something that you need to describe to your users so that they know what to send and what to expect to get back. If you are using hypermedia, then the next thing to think about, you need to document your links. So you need to tell people from this particular resource, where can I go? So this is documenting any relations and the sort of resource that if you follow a link with that relation, where will they end up? And then you also need to let them know where what they'll find when they get there. And this ties back to the consistency and the unique use of relations. If you haven't reused the same relation to point to two different resources, then this makes your job much easier here when you're trying to document where people are going to get to when they follow a link with a particular relation. So that's stuff that I think you should document. And now I'd just like to briefly talk about what you shouldn't document. And there's one thing, URIs. In the main content of your documentation, I don't think you should mention URIs at all. The only time someone needs to know about a URI is when they're actually, you're offering an example, this is how you call the resource. At any other point, if you put URIs in front of people, you're asking them to parse the structure of the URI and figure out what on earth you're talking about. And that requires them to do the mapping themselves from the problem domain that your API deals with to the URI structure that you've chosen to use. The only time they need a URI is when there's an HTTP client actually trying to make a request. So you may have to mention URIs in the documentation, but they absolutely should not be front and center. If you're using hypermedia, and I say this from bitter experience, if you document URIs too prominently, people will look at them and will not bother following links and will just hard code all the URIs in their client. And you think that you've spent all of this time making your API level 3 and all the robustness benefits and you can freely evolve it. And then someone writes a badly written client because you've led them in the wrong direction with your documentation. And all of a sudden your level 3 API is now a level 2 API. And that might not be too bad, but you then roll out a change to your API expecting that it will be fine because everyone's following links, and it breaks. And depending on the structure of your organization and who has most clout with management, the client team might say, well, we didn't change anything, and it broke. It's the server team's fault. And you might then say, well, they shouldn't have written a badly written client. And while you're having this bun fight, someone is probably going to tell you to put it back the way it was and stop breaking people. And at which point you've backed yourself into a corner, and now you can't evolve your API. So when you're thinking about documenting your API, even if you're not using hypermedia, but particularly if you are, don't make too much mention of URIs. They're not that important. They're only important when at the kind of the HTTP client level. Think more in terms of the resources and things in terms of the problem domain that people are used to. So now I've touched on a few of the things that you can get wrong. And as I said at the start, a lot of this is born from my own experience. And I'd like to show you some documentation that we produced for the middleware provisioning service that I mentioned. And hopefully you can learn a little bit from my mistakes. So this is the API documentation for an administration server that can provision and configure middleware. It had support for provisioning various bits of middleware, some of which you may have heard of: Gemfire, now Apache Geode, key value, memory key value store, RabbitMQ, a messaging product, TC Server, which was a commercial Tomcat offering. So to begin with, it's not too bad. It's broken down into the different types of middleware that were supported. But then say we switch to TC Server, and I'm just greeted with a sea of URIs, and all of a sudden I thought, hang on a minute, you said that TC Server was something to do with Tomcat. I'm expecting to see things about web apps and starting and stopping things and configuration files. And it's very hard to find that information. It's all here, but the structure is making it difficult for you to find what you're looking for. There are descriptions on the right-hand side of each endpoint, but things aren't broken down. The URIs, to my mind, are much more the most prominent piece of the documentation. So one, it's encouraging people to use URIs when they shouldn't be, and two, it's making it very difficult for people to find what they're looking for. If we dig into the documentation for an individual resource in the API, I was talking before about cross-cutting concerns and kind of documenting things up front and then not having to document them again. That's something else we got wrong here. We've documented the HTTP status codes that you can expect. So every single resource in this API, we've documented that if it works, you'll get a 200 back, and if something goes wrong on the server side, you'll get 500. In this case, this resource might not exist, so you can get 404 back. None of that is very interesting on a resource-by-resource basis. That's standard HTTP semantics. It's just noise. When someone is specifically interested in finding out what this resource can do, that's extra stuff that they need to read and figure out if it's interesting or not, and then ignore. So put all that up front, or don't document it at all if you're not doing anything out of the ordinary, and it means that people can focus in on the information that's resource-specific much more quickly and easily. Just to end with this on a slightly more positive note, one thing that I think we did get right is for every resource we've included example response bodies showing the structure of a response that you can expect to get back. That can be really helpful when someone's trying to write a client. They might be trying to maybe to stub out the service, and so they could use these example responses to stub it out and to test against. And in the when we were implementing the service in the documentation, we went to great lengths to ensure that these example responses were accurate by actually driving the service while we were producing the responses. So these aren't handwritten, so there were some guarantees that they would be in sync with the actual live service that people were coding against. Okay, so on a more positive note, I'd like to now give you a concrete real-world example of what it looks like when you get the documentation right. So as I've talked a bit before, I'm quite a big fan of GitHub's API documentation. So GitHub's API documentation is structured pretty much as I've been describing. It has an overview section up front where they describe everything that applies across the whole of the API. So there's things in here like their use of HTTP verbs, how you authenticate against the API, their use of hypermedia, pagination, rate limiting, etc. These are things that all apply across every resource in the API. And they've documented them very nicely up front, and then any individual specific resource doesn't really make mention of them. I think they occasionally link back to the main section, the overview section, but there's no need for it to be repeated for every single resource. To give an example, they've defined, they've said we strive to use appropriate HTTP verbs, and then they've also described how they treat put and patch. And they've also made it clear that you can use post where you would use patch. They say, patch is relatively new and uncommon, so they also allow you to use post as a kind of a synonym for patch. So they've defined their interpretation of what they do with put and patch, and then they've applied that consistently across the whole API. The other thing that I think they've done really nicely is then if you look at, so they have their overview section here, But then the API is now also broken down in terms of the problem domain. So you're thinking about GitHub, so you're thinking about issues and repositories and pull requests. So say you're looking at the API and you want to query a GitHub issue. You want to make a REST API call to find out about an issue. So you're thinking about issues, you're not thinking about URIs at this point, so you can just look in the documentation and go to the issues section. And then now still, there are no URIs. They're still breaking stuff down by, right, get a single issue. How do I do that? And only now do you see a URI on the screen. So they've helped you to get to exactly where you want before they even show you a URI. It lets you kind of stay in the domain of the problem you're trying to solve rather than the domain of the implementation and the URI structure. So it makes it very easy to navigate. And they also have nice example response bodies showing you what you can expect to get back. Another nice thing from an implementation perspective with the GitHub API, one thing is that it's all open source, available on GitHub, so you can go and look at it and see what they did, see how you documented it, how they document it. I recommend doing that. It's written in Ruby. It uses a Ruby-based tool chain, but I still think there's quite a lot can be learned from the approach that they've taken. And one thing that's really nice is that all of the text you see in the API is written in Markdown. So it's just Markdown files. So it's written in a format that is nice and friendly for writing documentation, which I think is writing documentation is hard at the best of times, but using a tool that's well suited to the job such as Markdown can make it a lot easier for you. Okay, so having looked at some examples of bad and then good RESTful API documentation, I'd now like to talk about a few different tools that you can use with kind of a focus for trying to document an API that's been implemented using Spring. So I think the first tool I ought to mention is Swagger. So quick show of hands, how many of you have heard of Swagger? Pretty much everybody, as I suspected. It seems to be, I think, if you say to someone, I have a REST API, how am I going to document it? Most people would, if it's not their first thought, they would certainly think of Swagger as a tool to use. There are two parts to Swagger. For the few of you who aren't familiar with it, there's a core specification that describes a metadata format that basically describes your API. You can actually use Swagger in two different ways. You can produce that metadata and then use that to auto-generate an implementation, or you can produce that metadata from your implementation and then use that to generate some metadata. I'm more interested in the latter case, so the API implemented using Spring MVC, and then you're trying to document it. To help you with that, there was a project that was called Swagger Spring MVC that has now been renamed to SpringFox. It's not part of the official Spring portfolio, but it is basically an addition to the Swagger ecosystem that lets you use Swagger with Spring MVC. So the main benefit with Swagger is that you do get quite a lot for not much effort. You can take an existing Spring MVC app, add Swagger to your class path, a little bit of code, and some API documentation will pop out the other end. The problem, though, unfortunately, is that there's a pretty big but. That API documentation, in my opinion, isn't very good. And hopefully I convince you that it's worth taking the time to produce something that's a bit better. To give you a few examples of some of the specific problems with Swagger. Now, this first one may not be a problem, depending on how RESTful your API is and how RESTful that you want to be. But the Swagger core team, so this isn't specific to the Swagger Spring MVC integration, they made a decision that they're not going to support hypermedia. So if you have a level 3 API, Swagger shouldn't even be on your short list of tools to choose. You should just forget about it completely and look for another one. If you have a level 2 API, then it might still be an option for you, but bear in mind that it will hamper you should you ever try to move to level 3, because then you'll have to redo all of your documentation. This one is a bit more generally applicable. Now, you might notice some similarities between this and the API documentation I showed you for the middleware service that we worked on. When we worked on that, we looked at different ways of documenting APIs and quite liked Swagger. We hadn't gone through the painful process of having done it and put the documentation in front of users and got their feedback. There were a few things that were limitations in Swagger, which is why we didn't use it. The main one was the lack of hypermedia support. So the middleware service I showed you was all hypermedia based. But what we produced was heavily heavily inspired by Swagger, but unfortunately it became apparent that that was a mistake because the URI-centric structure, as I've described, made it very hard for people to navigate the documentation, and it also encouraged people to hard code URIs into their clients, which essentially meant that we ended up with a non-hypermedia-based service with all the brittleness problems that brought with it. This problem is specific to the Swagger approach, where you're trying to figure out from an implementation exactly how the API will behave. So this one's actually been fixed, but I hope it illustrates a general problem with the approach. What Swagger does is it introspects your application context and finds all of your controllers and all of your methods that are annotated with request mapping, and then tries to figure out what that method might produce. So in this case, Spring Framework had introduced a new response entity return type, which on a controller allowed you to encapsulate 3 pieces of information. It allowed you to tell Spring the status code for the response, any HTTP headers that should be sent in the response, and the body itself of the response. At one point, Swagger didn't understand that, and it thought that the response entity was going to be just the body of the response. So this documentation is telling people that in the body of the response to this request, they're going to get a status code and a body, so a body nested within the body, and some HTTP headers. It's something that they fixed, but I think it illustrates the approach that they've taken means that as the framework that you're using to document your API, as it evolves, if the tool that you're using that is introspecting and the way that you've implemented your API, if it doesn't have a complete understanding of the framework that you built your API with, so in this case of Spring MVC, there may be certain features that you'd like to use that your documentation tool doesn't understand, and therefore you either have to make a choice. Do we produce documentation that's wrong, or do we abandon the tool and take a different approach to the documentation? Another example, and this one is still a problem, or it was certainly a few days ago, you can return an HTTP headers instance from a request mapping method on a controller. And this basically tells Spring MVC, I just want to return a response with these HTTP headers and no body. So you can have your request mapping method that returns HTTP headers and annotate it with response status to provide the status code. Again, the Spring MVC Swagger stuff doesn't understand that. HTTP headers is actually a map. So this is telling people that the response is going to contain an empty map for the body. Not quite as bad as the previous example, but again, it's an example of it not having a complete understanding of exactly how Spring MVC works that can lead to mistakes and inaccuracies in the documentation. Another problem with it is that it's very heavily annotation-based. Because it relies on you using the implementation to describe your API, the only place that they've got for you to describe what a particular resource does is by wrapping that text in an annotation. We followed this model when we implemented the API documentation in the middleware service. And I can tell you, writing documentation in annotations is horrendous. It's a really, really painful experience. And maybe for the odd sentence or two, it's okay, but when you want to write a more detailed descriptive paragraph or more, annotations they're not pleasant when you're writing them, and then also when you're going back to look at the code, you can end up with a Spring MVC controller that is 80–90% annotations with walls of text, and the actual implementation is a handful of lines in comparison. And lastly, it has difficulties with the introspection model, means that you end up having to repeat yourself. So one specific example here, they don't understand the response status annotation. This one could be fixed. I think you could refine Spring MVC Swagger support, but as it stands today, they don't understand that. So you have to add a second annotation that is basically providing the exact same information, which is not good for all the reasons that you normally try to avoid repeating yourself. Things will get out of sync, and you'll end up with your service and your documentation not matching each other. A more problematic variant of that, and one that I think this is just a fundamental flaw of the approach, is that, so here there's an exception handler that handles an illegal argument exception and returns a bad request response in the event of an illegal argument exception being thrown. But that's something that's happening at runtime, and it's very difficult for them to do static analysis of your request mapping stuff and figure out that that's what's going to happen. So that means, again, you need to repeat another annotation to tell them that it's possible to get a 400 response back. And that one, as I say, because this one you can't figure out via static analysis, there's a bit of, albeit in this case very simple, runtime logic, returning this particular response type. You just can't find that out by, short of parsing the bytecode. They can't figure this out. So I think you're always going to butt up against this sort of problem if you use a tool like Swagger, because it's trying to figure things out from the implementation. If it doesn't have a complete understanding of that implementation and all of your logic, it's not going to be able to get the right answers. Another example would be if you're using Jackson and a custom JSON serializer to control the structure of a response. It's not going to know that you've maybe added some extra information to the payload or masked some things out. If you do a simple thing where you're using some of Jackson's JSON ignore annotations, it can probably figure that out. But anything where you're doing actual logic in a custom JSON serializer or a deserializer, it's not going to be able to help you there. And you're going to end up with documentation that doesn't match the behavior of the service. So if you're using Swagger, and perhaps now I've convinced you that you might want to look to moving elsewhere, there's a very nice tool called Swagger to Markup, which will take an existing Swagger metadata file and generate either ASCII Doctor or Markdown from that. So you might have invested loads of time in adding all those annotations and things to your code to document your API, but now you're thinking you'd like to move to a different model. Maybe you'd like to write your documentation in ASCII Doctor or in Markdown. You can take that metadata file that's generated via Swagger, pass it into Swagger to Markdown, and Markdown or ASCII Doc will pop out the other end. What I'd recommend once you've done that, what you do, delete Swagger from your code base, get rid of all the annotations, and then use that Markdown generated file as like a jump start into documenting your API in a way that's a bit easier to write, and hopefully in a way we'll show you with some other tools, you can then keep accurate and in line with your service. You saw this briefly in the keynote last night. Dave showed you this when they were implementing the API in the keynote last night. If you use HAL as the response format, then there is something called HAL Browser available. And this builds on the fact that if you're using HAL, it means that your responses all come back in a well-defined structure. All of the links will be in a specific place, and it understands how to grab those links out of the responses and can allow you to navigate around the API in your browser. And I can quickly show you that now. I think, yeah, I've got that running. So hopefully. No, maybe I don't have it running. Hang on. Here we go. I didn't. Right. So this is just a simple Spring Boot app with Spring Boot's actuator enabled and with HAL Browser on the class path. So HAL Browser is just a very lightweight bit of HTML and JavaScript. So it's performed a GET request against the root of the service, against /actuator, and has got this response back. And it understands, because this response is formatted using HAL, it understands that these are all of the links. And these are all the places that I can go. So it's pulled those out, and I can now click around. So for example, I can perform a GET request on the health endpoint just by using the browser. It tells you that my service is up and running. Another nice thing that you can do with HAL Browser is you'll see there's all these doc links here. So the HAL specification defines the concept of this curries section. And it uses a templated URI to tell you that basically for this piece here is basically saying for any particular relation, I can go to /doc/hash Spring Boot actuator and then the relation and get some documentation about that particular endpoint. So what Spring Boot does is it pre-packages some documentation. So I can go, for example, to the health endpoint again, click on the docs link, and the browser takes me to that link for the health endpoint. So it lets you, I wouldn't say that HAL Browser is the answer to documenting your API, but if you're using HAL as the response format, it's a very nice way to put the documentation that you actually want people to look at just one click away or one link away from the service. And you don't even need to be using HAL Browser to kind of get at this. Anyone who'd even curled the index of the service and they see that curry section in the documentation, if they understand the HAL spec, then that immediately tells them where they can go to read the documentation for your API. So now I'd like to talk to you a little bit about Spring REST docs. So this is a project that, as I said at the start, this came out of my experience of trying to document the middleware service and trying to address some of the problems that I've talked to you about. And what I'd like to do is I'll take you through some examples of using Spring REST docs, some of the thinking behind it, and then we'll move on to actually showing you in action and using it to document a service. So there were three main driving principles to developing Spring REST docs that kind of govern the design choices that I made. One thing that I wanted to do is to write as much as possible in a format that's designed for writing. So I don't find writing documentation particularly easily. Being concise and yet conveying exactly the right information, I think, is a difficult job. And if you're trying to do that with annotations, you're trying to do it with, you're trying to do a difficult job with a tool that isn't really well suited, and that only makes the job harder. So I wanted people to be able to use a tool for writing the documentation that was well suited to writing. I also wanted to avoid using the implementation to provide the documentation. This kind of relates to using annotations. They're not a very good way to document things, but also in a modern Java-based REST API, there are many steps between your implementation of a controller and the HTTP layer. So there are many steps potentially between an HTTP request coming in and that request hitting your controller. And on the way back out, there are potentially many things between the response being returned by your controller and that actually getting written into the HTTP response. Jackson might be doing some serialization. You might be using Spring MVC's controller advice support. There might be exception handlers involved, and you're using JAX-RS, you might have an exception mapper involved. There's all sorts of pieces involved in that pipeline. And if you try to use the implementation, it means that you have to have a complete understanding of the framework that you're using and exactly how it's going to behave at runtime for the documentation to be accurate. And I wanted to avoid that because I didn't want to be coupled to having that understanding of the framework. So I wanted the framework that you're using to implement your API to be able to evolve happily at its own rate and add new features without the documentation tool then becoming out of date and having this problem of constantly having to play catch up. I also wanted to be able to provide some guarantees that the documentation's accurate. So I wanted, you could say that I'm aiming for test-driven documentation. You know, I want my tests to tell me that what I'm documenting is actually what the service is going to do. The GitHub API stuff that I talked about before, one problem that they have is all those example requests and responses, they're just checked into source control. They're just Ruby hashes. And they have on occasion got out of sync with the service because there isn't any checking against the actual live service itself. So that's a problem that I also wanted to try and address. So that led me to using ASCII Doctor. How many of you here have heard of ASCII Doctor? Not many. And how many of you have used it, of that small handful? Wow, 2 people. Okay, well, if nothing else, hopefully you'll go away today and go and look at ASCII Doctor. How many of you have used Markdown? Oh, maybe half of you. Okay, so ASCII Doctor is kind of like a souped-up version of Markdown, and it's got some nice support for kind of structuring the documentation a little bit more than Markdown does. It's arguably better suited to writing more verbose documentation. Markdown works well for kind of a short single page. ASCII Doctor's got lots of nice stuff for producing books or PDFs or whatever format web pages, all sorts of things. Next thing I wanted to use was Spring MVC test. So this kind of tied into I want to do something at test time. I want to offer some guarantees that the testing, that the documentation is accurate by coupling it in with the tests, so that when I run my tests, I get some assurances. How many of you have used Spring MVC test to test a Spring MVC API? About half of you. Okay, well, we'll dig into that in a bit more detail, and I'll show how you can use Spring MVC test, both with and without Spring REST docs. And thirdly, it uses Maven or Gradle, so it's driven as part of your build, so you can generate your API documentation as part of continuous integration cycle or what have you. So to dig into this in a bit more detail, this is a very simple test method using Spring MVC tests, mock MVC support. So the first line here is saying to mock MVC, I want to perform a GET request against slash. So mock MVC, you give it your application context, and it understands about all of your controllers and your request mappings and all sorts, and understands that there is an endpoint mapped to slash. But it also understands all about, because it's actually running code, it understands about your use of JSON serializers and exception handlers and controller advice and all sorts of stuff. This is exercising your whole application from basically a mocked out HTTP servlet request being received by Spring MVC to that reaching your controller and then coming back out again and giving you a mocked up HTTP response. So it's driving stuff at the HTTP level, which is also the level that your clients will be dealing with, rather than trying to jump straight into the implementation and maybe cutting out some things that you've used to get your API behaving the way you would like. So in the second line, we have a very simple assertion here. We're not testing this particularly rigorously, just for the purpose of keeping it all on one slide. So we're saying we want to call GET. We want to do a GET request to the index of the service, and we expect to get back an HTTP 200, an OK response back from the service. And then we're using JSON path to make some assertions about the format of the response body. So JSON path here is saying that I expect to find some links, and I expect to find a notes link and a tags link. And if those links were absent from the payload, my test would fail. And in step 5 here, that's when Spring RESTdocs enters the picture. So what I'm doing here is saying, and I want to document this request that I've just made against the service. And index is basically just saying, and put the documentation in a folder called index. It's just controlling where on the file system the auto-generated documentation ends up. And what that will do is that will generate some snippets for me, ASCII doc formatted snippets. So here, for example, I was doing a GET request against slash, the index of the service. So it's saying, right, well, if I wanted to do that with curl, so say you want to include in your documentation, here's an example of how to drive this resource using curl. Here's the curl request that you would make. And we know that this is the exact curl request that you should make because your test passed, and it will do the equivalent of what the test has just done. And then you can import that snippet into your ASCII doc document, and it kind of does a nice bit of syntax highlighting and formatting and what have you. Another snippet that it will generate for you is showing you what the HTTP response will look like. So you can include example responses in your documentation that have been auto-generated by the test. So you have a guarantee that this is exactly what the service will produce because you've driven the service to produce it. And again, you can then import that into your documentation. And again, you get some nice syntax highlighting here. This is one of the advantages of using something like ASCII Doctor. There's a huge ecosystem around ASCII Doctor. Various plugins, it's got a nice plugin model, things that you can add to it. And so by using a tool like ASCII Doctor, you can kind of build on everything that they've done, all the tooling that they've produced to write great documentation. All of that is available to you. So you can see here, in the top of the snippet, I'm saying this is source, and the format of it is HTTP. The syntax highlighter is then smart enough to know, okay, this is HTTP. The content of this block is HTTP. I'm going to highlight that appropriately. And I believe it's even smart enough to look at the content type and know that this is a JSON variant and is then formatting the response with the keys and values syntax highlighted appropriately. So there's an awful lot that you can get by making use of the ASCII Doctor ecosystem. If you then want to take things a step further, so say we want to document our links that we have in our API. So here's step 1 again, I'm making my document call and saying write things out into the index. But then changing from the previous scenario, I was using JSON path and some assertions to say I expect to find these links. What I've replaced those with now, though, is some code, right, I want to actually document those links. So I'm saying to Spring RESTdocs, in step 2, I want to document the links, and then in steps 3 and 4, I want to document a link with the notes relation and a link with the tags relation. And what will happen there is if the notes link or the tags link isn't present in the response, the test will fail. And equally, if there's a link in the response that isn't notes or tags, so one that you haven't documented, the test will also fail. So Spring RESTdocs If your tests are all passing, then you know that you've documented all of the links. So it gives you some assurances that what you've documented is actually what your service is returning. And then we're also documenting the response field. So in the response body, I expect underscore links to appear in there. And that path, again, is just a JSON path. And again, the same rules apply. So if you claim that something is in the response, you try to document and it isn't there, your test will fail. And if you fail to document a portion of the response, then the test will also fail. So by the fact that all of your tests pass, then you have some assurances that your documentation is accurate. And that produces some snippets for you in a similar way to before. So here's a snippet that describes the links in your API. And again, you can import that into your ASCII document, and you get a nice table. You can link off to other parts of the documentation to help people navigate around. And again, the response body format, again, it gives you a nice snippet that you can then import into your documentation to describe that particular resource and the responses that you can expect. And you can see in the middle column here, it's automatically identified that the type of the links thing in JSON terms is an object, so it's a map, if you like. And it will automatically detect for paths that you offer what type people can expect. And Spring RESTdocs will do that for you by inspecting the response body and looking at the types in the JSON to figure out what should go in there, which makes it a bit easier for people writing clients. They know what types they should expect to deal with when they're dealing with a particular part of the response payload. All right, so now I'd like to show you, so what would you do? How would you go about adding Spring RESTdocs to an API? Actually, before I do that, I'll show you, I showed you a few snippets there kind of in isolation. I'll just show you the end result, what you can end up with. So this is the complete documentation for the note service that I've kind of touched on a bit throughout the presentation. Written in ASCII doc with all of the snippets generated using Spring RESTdocs. So it's following the structure of the GitHub API documentation with the overview section, HTTP verbs, status codes, etc. And you'll see all of the snippets that are included in the documentation, all of these little parts of the example responses are generated by Spring RESTdocs. So they're things that you know will match what the service can do. That's one format of documentation you can produce, which is kind of GitHub-like. You can also, assuming the internet is working, I might just have to describe this to you while the internet does its thing. You can also produce a getting started guide, which describes to you, kind of walks a user through using the service. You're not, by using something like ASCII doc to produce the documentation, you're free to structure it however you like. You're free to produce whatever format of documentation you like. You're trying to produce a terse, very concise API guide for your documentation, or you're trying to kind of almost produce something that's like a tutorial, but you want some assurances that the contents of the tutorial are accurate. Okay, so let's try and now take you through using Spring RESTdocs to develop a RESTful API, to document a RESTful API, I should say. Okay, so you saw in the keynote on last night, Dave used the Spring Tool Suite's UI to produce a kind of a skeleton Spring Boot application. I'm going to now try it, although I suspect it's not going to work with the wireless, but let's give it a go. Let's produce a skeleton app for our REST API. So I'm using the latest milestone of Spring Boot. I'm going to use Spring Data JPA, Spring Data REST, RESTdocs. I'll use H2 for an in-memory database while I'm developing. I'm also going to use Spring Boot's DevTools. I use Gradle to build the API. There's some nice things in Gradle that kind of make writing documentation quite easy. I'd kind of shorten the feedback loop. I'll show you some of those. Let's give that a go, see if it works. Doesn't look like it's going to. Okay, let's cheat. Okay, so here's one I prepared earlier. this is what the, if the wireless was working, this is the skeleton project that would have been produced for me. So let's run Gradle Eclipse to generate some Eclipse metadata, and then we can import the skeleton application. Okay, so import the existing project. Okay, so now we have our simple application here, and it's just a very simple skeleton Spring Boot application. Not a lot to it at the moment, although we can actually run it. And let me stop. Did I leave the other one running? No, I don't think I did. Right. So we run that as a Spring Boot app, and that will actually give us a functional, albeit very limited, API. So you can see now we've just got a response back with a single link. This is something that Spring Data REST provides for us automatically. It provides ALPS support. I haven't really described what ALPS is. It's basically a profile that kind of describes the API. And so we've got, that's our service up and running with a single link to it. So what we need to do now is let's start fleshing out our API a little bit. So let's add the note entity. So we're going to have a note in our API. We're going to let people create notes. So let's create a JPA entity with just a few fields on it. Let's have an ID, a title for the note, and a body for the note. Okay, and there we go. So now the last thing we need to get kind of the note stuff up and working is we need to create a Spring Data JPA repository to go with it. So we can create a new interface. This is something you saw some of this in action in the keynote last night. So we're going to extend CRUD repository, and this is the power that Spring Data REST kind of exposes for next to no code is incredible. So there we go, note, we're using long as the IDs. So now that gives us a repository that will allow us to create and query notes. And because we're using Spring Data REST on top of Spring Data JPA, we're essentially done. That is a very simple RESTful API that allows us to create and list various notes. We drop back to the service and curl it again now, you'll see that there's now another link appeared. So there's now a notes resource available in our application. And if we curl that, we can see that there aren't any notes in the service at the moment. You may have also noticed that I didn't have to restart the application while I was writing all of that. That's thanks to the new dev tools that are in Spring Boot 1.3. As I was changing stuff, you may have noticed in the console here that it was restarting the application context. It uses a throwaway class loader, so anytime I make a change, it throws away the class loader, creates a new one, and reloads the application with a new class loader. So as I'm making changes, I get kind of live reloads of what's going on in my application, which can dramatically shorten the feedback cycle. Okay, so we've implemented our service, and we got it up and running, such as it is. Fairly basic, but good enough for our purposes. So now we want to introduce mock MVC to our tests. So this is the test that the initializer, Spring Initializer, gives you out of the box. So it's just a very simple test that basically just checks that your application context loads. So let's enhance that a little bit to introduce Spring RESTdocs into the mix, Spring MVC test into the mix, and then actually start testing our API. So the first thing we need to do is we need to tell the test framework that we want a web app here. So we're working with a web app, so we want it to start our app as a web app in the tests. Actually, let me stop that version of it. So if we want to introduce Spring MVC test, the first thing we need access to is our web application context, because that's what describes all of the endpoints that are in our application. So we can tell Spring to auto-wire the application context into our test. And then we need a Spring mock MVC instance. And we'll create that we'll set that up in an @before method. So this is something that will run every test, before every test for us. And we say to make mock MVC, and we're saying I want to use web app context setup. So this is basically saying to mock MVC, I want you to create an instance of yourself based on the contents of this application context. So it knows about the Spring Data REST controllers that have been created off the back of our JPA repository implementation. And that's all. That's it. We don't need any more configuration. So let's we're not testing if the context loads. Now we're going to do something a little bit more sophisticated. So now let's test the index of the service. So I say to Spring mock MVC, that I would like to perform a GET request against the index of the service. And I expect to get back a response with a status of OK. And that throws exception. There we go. So I can run that now, and we're now doing a very basic test of our service. So we've introduced Spring MVC test into the picture now. So we're testing, we're calling / on our service, and we're making sure that we get an OK response back. So now let's add Spring REST docs into the picture. So say we now want to start generating some documentation for the index of our service. What do we need to do? So the first thing to do is to add a new field to the class, a new REST documentation field. And this is basically, this encapsulates Spring REST docs configuration. And it tells it which directory I should write any generated snippets out into. And we annotate that with @rule. So this is using a JUnit rule. So this is something that JUnit will automatically call for us for each test. And this is kind of the hook point that allows Spring REST docs to understand when a test is being run and it needs to do some snippet generation for you. So that rule is basically hooking together JUnit, which we're using to run the test, and Spring REST docs, which we're using to generate the documentation. The other piece of hooking up that we need to do is we need to also tell mock MVC about Spring REST docs. We need to bring those two together so that Spring REST docs, in addition to knowing when a test is being run, it also needs to know when you're making a mock MVC call. So we can do that by applying some configuration to mock MVC. So we apply our documentation configuration using the REST documentation JUnit rule. So now we've coupled everything together. JUnit and mock MVC and Spring REST docs can kind of now all work in collaboration because we've joined them all up. And that's the kind of that's it in terms of the setup that you need to do. You might want to put that in an abstract superclass that all of your REST documentation kind of tests extend, because it's configuration that should apply across the board. There's nothing kind of specific in there that's specific to these tests. So we're performing a GET request on /, but we're not actually generating any documentation yet. So now we need to add some documentation to this. So undo document. And let's use index as the identifier, just controls where the documentation gets written to. And then if we run our tests again now, hopefully they will pass. Yep, there we go. And we should also see that we now have some snippets generated that are based on the request that we've just made on the service. So there's a curl request snippet. So how would I use curl to make the same request? And this is a very simple example. Spring REST docs understands things like query parameters and things. So it will generate the correct query string for you. It will include the request body for you in the curl request that you would need to send to exactly mirror the mock MVC call that you've just made. A snippet for the equivalent HTTP request. So in theory, you could open a telnet session to the service, paste that in and send it, and it would do exactly the same thing. And also shows you the HTTP response that you should get back. Again, this is what was produced by the service, just kind of wrapped in the right formatting for ASCII Doctor to be able to consume it. Okay, so now we've done that, what we need to do now is we want to introduce ASCII Doctor into the picture. So we've generated all of these snippets. Now what can we do with ASCII Doctor to import them, and how do we go about getting that set up? So to do that, we need to drop down into our Gradle build script. So this is the script as is, as was generated, or would have been if the wireless was working, the Spring initializer. So we need to add a few dependencies to it. So the ASCII Doctor Gradle plugin is not available in Maven Central. So we need to add the JCenter repository. And let's add a dependency for the ASCII Doctor plugin. And once we've got that dependency in place, we then need to apply that plugin to the project. So that just tells Gradle that in addition to this, the bit above essentially just added it to the class path of the build. And we now need to apply that plugin so that it will actually run as part of the build. And then we need to, so that's it in terms of basic ASCII Doctor. Adding ASCII Doctor to your Gradle build is as simple as that in its kind of most basic form. So now we need some source. So we need a new source folder. So by default, the ASCII Doctor plugin looks in source docs ASCII doc for any files that it uses to generate the HTML output. And let's create a new file in there, a new ADoc file, and let's have so that's our very basic ASCII doc file. And if we drop down onto the command line and we ask Gradle to run, that'll run the ASCII Doctor plugin and process that very basic file that we had and spit out some HTML. So we can see here, there we go. So that's our very basic ASCII doc file with the heading that I entered. So and now I'll show you why I chose to use Gradle for this. In the latest releases of Gradle, they introduced something called continuous build, and this really helps you shorten the feedback cycle when you're writing your documentation. So if I rerun that now with -t, Gradle will now watch the inputs of the ASCII Doctor build task for any changes, and if I change any of those inputs, it will automatically rerun the right bit of the build. So let's just, if I shrink this down a bit, and let's just pop this over here so that you can still see it. So if I change this, Gradle will rerun the build. So if I change that, you'll notice that Gradle's noticed that that's changed and it's rerunning the ASCII Doctor task for me automatically. And if I refresh my browser, there we go. Gradle's rerun that and regenerated the file for me. One thing, unfortunately, that it doesn't do is it doesn't understand that our tests are heavily involved in the generating of our documentation. So if I change anything in here, nothing's happened. Gradle didn't know that my tests are an important part of the ASCII doc output. But we can help it. We can give it some more information that lets it know to do, lets it realize that any test changes also need to regenerate the documentation. So if we go back to our build Gradle file, so the first thing that we want to do is we want to declare a property in the build that basically, this is just basically to allow us to reuse the output location without having to type it in multiple times. So this matches the output location that I specified when I was configuring the JUnit rule in the tests. So we set up that property in our build, and then we tell the test task that it had adding to its output this directory, the snippets directory. So now we've got the snippets directory hooked up as an output of the test. So Gradle now knows that when the tests run, they're going to produce files in this directory. And then the next thing I need to do is I need to say to ASCII doctor, okay, so the ASCII doctor task, now in its inputs, it's going to use the snippets dir. So now the ASCII doctor task knows that that snippets directory, which is an output of the test task, is an input of the ASCII doctor task. And by doing that, we're hooking the tasks together. And then we tell Gradle, yeah, ASCII doctor task depends on test. So this just helps it get the ordering right. It knows that it ought to run the test before it runs the ASCII doctor task. So if I save that now, I've changed the build script, so I need to restart the continuous build. So I run now the ASCII doctor task, and you'll notice that it's run the tests now. And if I go back to the tests and make a change, see that change in the Java code now triggered the build. And it figured out the main Java was up to date, but it's recompiled the tests, it's rerun the test task, and it's rerun the ASCII doctor task. So now any other, change it back again, save it, it triggers the build for me automatically, so I don't need to worry about dropping back to the command line, and it'll automatically regenerate the snippets as I'm making changes in the test. All right, so now I've got my build kind of quite nicely set up with a nice short feedback loop for while I'm working on my documentation. I can go back here, and now I want to import one of those snippets into my ASCII doctor document. And actually, we can make one last change here to help us. So ASCII doctor supports the concept of attributes, which is basically, it's just a variable that you can refer to in your documentation. So rather than me having to type in the fully qualified path of where the snippets are that I want to import into the documentation, I can just declare this attribute and reusing the snippets dir property that I defined earlier. And it makes it really easy. It's just a shorthand for importing the snippets. So I rerun the build, having made that change to the build script. I can then go back to my documentation, and so I can say, access the root of the service using Go, and then I can include my snippet, and so here I'm referencing that attribute. So the squiggly brackets are basically saying this is a variable, so substitute that attribute that I declared in the build file with what's inside the curly braces. So I'm saying inside the snippets, and now I used index as the identifier when I was writing the test. So I've said here index, so that means that those files are going to end up in the index directory beneath the snippets directory, and say, right, I want to import the curl request.a.doc file. And that change should trigger a build. There we go, Gradle reran the build. And hopefully, if the demo gods are smiling on me. There we go. So now I've got the curl request snippet imported into my documentation. So then I could go back, we saw it generated a few different snippets. So let's have a look at the response. What will the response be? So we can take that and say, right, let's pull in the HTTP response snippet. And again, that should trigger our build for us. There we go, and we've imported the response. I talked a little bit earlier on about the syntax highlighting that's offered. That almost couldn't be easier to set up. If you want to add syntax highlighting, it's just a single little piece of metadata you need to add to the top of your ASCII doctor document. So you say source highlighter, and there are various different source highlighters that are supported. And they vary a little bit if you want to go into a bit more detail and to configure the coloring of the highlighting. Some of them support languages that others don't support and things. It's all described in the ASCII doctor documentation. Highlight.js, in my experience, works pretty well when you're trying to document a RESTful API. And if we go back now, refresh here, hopefully, Did it rerun the build? Okay, well, the demo gods aren't smiling on me for that one. You'll have to take my word for it. You saw some of the examples of the source code highlighting in the presentation. That should be, if there were no gremlins, all it takes to get source code highlighting added. Sorry about that one. Okay, and so the next step that we might want to do is we might want to document some links in our service. So if we go back to the test, so now we've got our test before that was just not really verifying anything other than we got an HTTP response, an HTTP 200 response. Let's now document some links. So I can say to Spring REST docs, yeah, I want to document the links. And let's say link with rel. So let's document the notes link in the root of the service. So if I save that, and I go back to my tests, you'll see now that the tests actually have failed. So I can go and look, say, okay, so why have the tests failed? So you see I've got one test failure, and let's find a description for the link. So that failed because I didn't provide a description. I run the test again, and hopefully now, here we go, okay. So now it's saying links with the following relations were not documented. So my test has failed because I didn't document the profile link. So if I go back to my tests, and then I can say link, and then say, give it a description. So there we go. So I now documented both the links. So hopefully the continuous build will rerun the tests, and the test will now pass. And it's now going on to regenerating the ASCII doc. So you see now the test, they've verified that I documented all the links that were expected to be there. And finally, I'll just document, so let's say I want to document the response fields. And so let's say there's some links and a description to go there. And again, this is a very simple response structure, so there's only really the links in there. But if I hadn't documented something, again, the test would fail. But hopefully now we'll see, yeah, that test is passing. And we could go back and we could include those in our ASCII doc document if we wanted to. So the final thing that I wanted to show you, and I suspect given the problems I had a minute ago, this may not work, but let's give it a go anyway. The final thing is talking about shortening the feedback loop when you're writing your documentation. There's one last thing that you can do with Gradle. It has support for, how many have done any client website development, front-end stuff, and have any of you used live reload? So live reload it's two things. It's a server that sits and notices that things have changed, and it's a plugin for your browser that establishes a connection to that server and then automatically refreshes the page whenever something changes. So if having to flip to your browser and refresh the page is too much for you, you can hook in live reload support. And then as you're writing your documentation, you can have your documentation on one side and your browser here, and as you're writing it and saving it, Gradle's continuous build will run, and when the build is finished, the live reload plugin will automatically refresh your browser, so you can kind of get a live update to your documentation as you're developing it and changing it. Adding that to your Gradle build is pretty simple. Again, it's similar to adding the ASCII Doctor plugin. It's a matter of adding a new dependency to the class path of the build. And then once you've added that dependency, if you apply the plugin to the build, tell Gradle, yeah, we want to use that, please. So you apply the plugin. And then the last thing that you need to do is you need to tell the live reload stuff, what should I watch? What am I watching for changes that should trigger a live reload? So the last thing to add there is you just tell it, right, the route that you're looking at is, let's take the ASCII doctor task, because that's the thing that's producing the stuff that we want to trigger a reload. And the output directory, let's grab the canonical path of that output directory and tell. So that's basically saying to the live reload thing, watch the output of the ASCII doctor task, and whenever that changes, trigger a live reload for me, please. And then using that as a simple so you've got your continuous build running in one place with Gradle. The other thing then that you need to do is to then just run Gradle again, but run the live reload task. And this will set up the live reload server that you can then connect your browser to. So you need to install a plugin into your browser. So here I've got the live, so go back to the documentation. Which isn't working for whatever reason. Right, so then there's just a plugin that you have in your browser that you use to enable live reload, and that will connect to the live reload server that's running with Gradle. Fortunately, I can't show you it now, but it would then mean whenever I change the documentation, the auto-build automatically runs, and it refreshes the browser for you. So it gets that feedback loop out as short as you can for when you're working on your API documentation. All right, that's all I have for you this afternoon. So all that remains to say thank you very much. I hope you found this useful. If you try out Spring REST Docs, it's at 1.0 RC1 now. It hopefully will go final in a few weeks after the conference. So if I piqued your interest, please grab it, give it a go. It's not too late to get feedback in to influence 1.0. You can find me on Twitter, GitHub, or if you want to drop me an email, please do so. Thank you very much.